All right, here we are at the bottom of page 2 for section 10.5. We've been practicing, if you look at the top of the page, we've been practicing how to start finding the pieces that will allow us to create the graph of a quadratic, a parabola, without having to go through that tedious make a table, pick some x's, plug them in, do all the arithmetic, get your y's, plot the points, connect the dots, hope for the best, right? We're coming up with some strategic pieces, whether it's up or down, where it crosses the x-axis, where it crosses the y-axis, that's what we just finished, the y-intercept, and now that vertex, that point where it's going to be symmetrical on either side of it, that turning point. Let's find the vertex, and our formula for that is the x-coordinate of the vertex is equal to negative b over 2a. In other words, it's an opposite of the b value over 2 times the a value. And these are in standard form, so our a value in this case is negative 2, our b value is negative 4, our c value is negative 2. Notice I'm keeping the signs with these. Very, very important, okay? If you're getting, if you feel like you're doing these problems right, but you're off, your graph is off, your points are off, go back and see if it's because you aren't taking the signs with you. Watch for that, okay? And in this formula, make sure it's negative of whatever the b value is. So in this case, it's going to be the negative of negative 4 and 2 times the negative 2. So you take the entire b value, then take the negative of that, take the entire a value, and then multiply it by negative 2. Or I'm sorry, positive 2. Negative 2 is what we're using for a in this case. Yikes. Okay, so in this case, then you simplify here. Negative 4 is positive 4. 2 times negative 2 is negative 4. 4 divided by negative 4 is a negative 1. So we're halfway there to our vertex. Negative 1 is our x-coordinate. Now we need to find our y values. So we're going to plug negative 1 in for x. So we have y equals negative 2 times x squared minus 4 times x minus 2. We're taking that original equation here and we're taking our x-coordinate and plugging it in. And I have quickly run myself out of room here, so I'm going to just kind of slide over to the side here and finish this out. Negative 2 times negative 1 squared minus 4 times negative 1 minus 2. So order of operations, I square that negative 1, it becomes a positive 1. So negative 2 times positive 1. Negative 4 times negative 1 is a positive 4. And then minus 2. Negative 2 times 1 is a negative 2. Plus 4 minus 2. Adding these up, negative 2 plus 4 is positive 2. Minus 2 becomes 0. So the other piece of our vertex is 0. So this particular parabola that we're looking at right here, this particular equation, has a vertex, a turning point at negative 1, 0. And we can imagine that it goes down from here because we've got an a value that's negative. It crosses the y-axis at negative 2. We'd have to do a little bit extra math to get the x-intercepts, but that'll come later. But you can see how we can start putting the pieces of the puzzle together to create the graph. Let's look at 24. What's different about this one? And again, I'll give you a hint. It's the one that we looked at earlier. What was different up here? Or you'll have to kind of go up the page a little bit, but what's different is it didn't have a c value. Okay, there's no c value. It's not going to change how we do this, though. In reality, our c value is just 0. Okay, it's not that it doesn't exist, we just can't see it because we didn't take the extra time to chisel in the 0. Okay, so the x-coordinate of your vertex, and this is one of those ones that it's almost so easy that you forget that you need to memorize it. And come test time, this is one of the most forgotten pieces because it just, you feel like, oh, I've got this, and you don't really take the time to rehearse it. So here, treat this like a formula. Treat it like you have to get it memorized because you will need it come test time. So the x-coordinate of the vertex is found by taking negative b over 2a. Negative b over 2 times a. In this case, our a value is 1, the number in front of the x squared. Our b value is 8. Our c value is 0. So negative b over 2a, our b value is 8. Our a value is 1. This is negative 8 over 2. It's negative 4. So far we know that the vertex is going to be negative 4 something. Okay, now to get our y coordinate, we plug in -4 for x to get our y coordinate of the vertex. When x is -4, where does that land us on the graph? So we go y equals x squared plus 8 times x. And, you know, we don't have to write the plus 0 in there. That's understood. So I'm going to take that -4 and put it right in here. And let's draw the multi-layered curtain here for a little bit of privacy as we do this problem. -4 squared is going to be a positive 16. 8 times -4 is a -32. This becomes a -16. 16 minus 32 is -16. So that was what we got for our y value. So our vertex is -4, -16. And we could kind of peek up. Oh yeah, it's going to open up. It's positive. It crosses the y-axis at 0, 0. Then that means we actually know one of the x-intercepts as well. So this little picture is starting to come together as well. So down here in the corner, we've kind of curtained it off a little bit here, but this is one for you to try. So talk it through, make sure you're understanding what's going on. Pause the video, try this one, see what you come up with for the vertex of this particular quadratic equation. Okay, so hopefully you took my advice and started rehearsing that formula for the x-coordinate of the vertex, -b over 2a. You wrote it, you said it as you were using it, and also hopefully you were able to get to the correct vertex, which in this case is 3, -4. That's the turning point for this parabola.